If you have an Accenture interview coming up for the Custom Software Engineer role, this is the only video you need to watch. Because I'm about to give you over 230 real, frequently asked questions across Python, SQL, OOP, Git, and SDLC, all in one place. Stick till the end, because I'll also tell you the exact mistake most freshers make in the HR round that gets them rejected even after clearing the technical rounds. Introduction. Hey everyone, welcome back to the channel. If you're preparing for an Accenture interview, especially for the Custom Software Engineer role with 0 to 2 years of experience, you're in the right place. I've gone through hundreds of real interview experiences, removed all the duplicate and repeated questions, and organized everything into one clean roadmap. We're talking Python fundamentals, OOP, advanced Python, coding problems, SQL, including joins and window functions, database concepts, Git, SDLC and agile, testing types, scenario-based questions, and finally, the HR round. By the end of this video, you'll know exactly what to revise, in what order, and how to structure your answers so you sound confident and clear, not like you've memorized a textbook. Let's get straight into it. Section 1, Python Fundamentals. Let's start with Round 1, Python Fundamentals. This is usually the very first set of questions, and interviewers use it to check if your basics are solid. First, they'll often ask, why is Python called an interpreted language, and how it's different from a compiled language? Be ready to explain bytecode briefly here. Next comes the classic, mutable versus immutable objects. Make sure you can list which data types fall into which category. Lists, dictionaries, and sets are mutable. Tuples, strings, and numbers are immutable. Then you'll get comparison questions, list versus tuple versus set versus dictionary, and when you'd actually use each one in real code. Don't just give definitions, give a one-line use case for each. After that, append versus extend versus insert, and remove versus pop versus they'll versus clear. These look simple, but a lot of candidates mix them up under pressure, so practice writing these out by hand. A very common trick question is versus equals identity comparison versus value comparison. Always give an example with two lists that have the same values but different memory addresses. Then, deep copy versus shallow copy, and how Python handles memory management, reference counting, and garbage collection. This is a favorite for testing depth. On the functional side, expect, asterisk args and double star quargs, lambda functions, and the trio, map, filter, and reduce. And finally, list comprehensions versus generator expressions, iterators versus generators, and the big one, what does the yield keyword do? And why are generators more memory efficient than lists? If you can explain this clearly with an example, you'll stand out immediately. Section 2, Python OOP. Now let's move to object-oriented programming in Python. This is where a lot of interviews go deeper. They'll ask you to explain the 4 pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. And trust me, just defining them isn't enough. Have a one-line code example ready for each. Then, method overloading versus method overriding. And the follow-up question that catches people off guard. Does Python actually support method overloading the way Java does? Spoiler. Not natively, and you should explain why. Next, multiple inheritance, multi-level inheritance, and hierarchical inheritance, along with MRO, method resolution order, and how the super function works. You'll also get self versus CLS, and instance variables versus class variables. Then the classic pair, static method versus class method. Know exactly when to use which decorator. They'll also test abstract classes versus interfaces, magic methods like init, str, and repra, and finally, duck typing. If you can explain duck typing with a simple real-world analogy, that's an easy points scored. Section 3, Advanced Python. This is where they separate freshers who have only studied syntax from those who actually understand how Python works under the hood. First, decorators, be ready not just to define them, but to give a real-world use case like logging or authentication checks. Then, closures and context managers, and how the with statement actually works behind the scenes. A big one, threading versus multiprocessing, and the question that almost always follows, what is the GIL, the global interpreter lock? And why does it make Python slower than a language like Java in certain scenarios? You'll also need to know the exception hierarchy, the difference between a syntax error and an exception, and how try, except, else, and finally all work together. They might even ask you to write a custom exception class on the spot. Finally, modules versus packages, pip versus conda, virtual environments and requirements.txt, and basic file handling, read, readline, read lines, write, and write lines. Section 4. Coding practice. Now, this is the part most candidates are most nervous about, the live coding round. Let me break this into 4 buckets so it's easy to practice. Bucket 1. Strings. Reverse a string or a sentence, check for palindromes and anagrams, count vowels, find character frequency, find the first non-repeating character, and string compression. Bucket 2. Numbers. Prime numbers, Armstrong numbers, perfect numbers, factorial, the Fibonacci series, GCD and LCM, and the classic, swap to numbers without using a third variable. Bucket 3. Arrays. The two-sum problem. This comes up constantly. Finding the second or nth largest element, finding a missing or duplicate number, rotating an array, moving zeros to the end, and finding the intersection or union of two arrays. Bucket 4. Sorting and searching. Linear search versus binary search. And you should be able to code bubble sort, selection sort, insertion sort, merge sort, and quick sort from memory. At least explain the logic, even if you can't write perfect syntax under pressure. My advice here, don't just memorize solutions. Practice explaining your thought process out loud while you code, because that's exactly what the interviewer is evaluating. Section 5. SQL Basics and Keys. Let's switch gears to SQL. Round 2 usually starts here. First, delete versus truncate versus drop, a guaranteed question. Then the keys, primary key, foreign key, composite key, candidate key, super key, and alternate key, and the specific difference between a unique key and a primary key. You'll also get asked about char versus varchar, and constraints like not null, check, default, and unique. A big topic here is normalization, 1NF, 2NF, 3NF, and BCNF, and when you'd actually choose to denormalize a database for performance. Then, clustered versus non-clustered indexes, the aggregate functions count, sum, average, min, max, and a very practical scenario question. How do you optimize a SQL query that's taking 20 seconds to run? Section 6. SQL Joins and Advanced Queries. This section is where SQL gets serious. You need rock-solid clarity on all the joins, inner join, left join, right join, full outer join, cross join, and self join. Draw them out with simple tutable examples while you practice. Then, join versus union, and union versus union all. Next, where versus having, and group by versus order by simple, but always asked. After that, subquery versus correlated subquery, exists versus in, and any versus all. Now the advanced stuff that really impresses interviewers, CTEs and recursive CTEs, and window functions, row underscore number, rank, dense underscoring, lead, and lag. And finally, the practical query questions you absolutely must be able to write. Find the second or nth highest salary, top 3 salaries department-wise, employees earning more than their manager, and departments with no employees. These come up in almost every single SQL round. Section 7. Database Concepts, ACID. Let's talk transactions. You need to explain ACID clearly. Atomicity. All steps succeed or none do. Consistency. The database moves between valid states. Isolation, concurrent transactions don't interfere with each other. Durability, once committed, data survives a failure. Beyond that, be ready for commit versus rollback and save points, isolation levels and how they connect to dirty reads, phantom reads, and repeatable reads, what causes a deadlock and how to prevent one, and basic locking strategies in SQL. Section 8. Git. Quick but important section. Git. Git versus GitHub, Git clone, and the typical team workflow. Git pull versus Git fetch, and Git merge versus Git rebase. Then, Git stash and Git cherry pick, Git reset versus Git revert. And the question that almost always comes up, how do you resolve a merge conflict? And what happens if the developers modify the same file at the same time? Section 9. SDLC, Agile, and Testing. Now let's cover process knowledge. This shows you understand how real software teams work, not just how to code. You should know the phases of SDLC and the difference between Agile and Waterfall. Then the Scrum roles, Product Owner versus Scrum Master. Terms like sprint, sprint planning, daily stand-up, and retrospective. And product backlog versus sprint backlog, along with user stories. On testing, unit testing versus integration testing versus system testing, regression versus smoke versus sanity testing, and black box versus white box testing. Also be ready to talk about assertions and basic debugging techniques you personally use. Section 10. Scenario-based questions. This is where they test how you think, not just what you know. Here are 8 scenarios you should prepare answers for out loud before the interview. 1. Your Python program is running slowly. How do you optimize it? 2. A SQL query takes 20 seconds. How do you speed it up? 3. How do you debug a production issue end-to-end? 4. A teammate's code is hard to understand. What would you do? 5. How do you handle merge conflicts across a team? 6. A customer reports a bug. Walk through your response. 7. How do you improve existing code without changing its behavior? And 8. How do you ensure code quality before pushing a change? For every single one of these, use a simple structure: situation, action, result. Keep it short, 30 to 45 seconds per answer. Section 11. Project and resume questions. This is where most candidates lose marks, not because they don't know the answer, but because they haven't prepared it in advance. Expect, walk me through your resume or your final year project. What was your specific role? Explain your project's architecture and database design, and why did you choose this particular tech stack? Also, explain one SQL query you used, what APIs did you integrate, what challenges did you face, and how did you debug a critical issue, how did you test your project, and what would you improve if you revisited it today? My tip: write out a 2-minute project summary and practice it 5 times before your interview. This single answer sets the tone for the entire technical round. Section 12. HR round. And finally, the HR round. Don't underestimate this. Tell me about yourself. Why do you want to join Accenture? Why should we hire you? What are your strengths and weaknesses? Where do you see yourself in 5 years? And do you have any questions for us? Here's the mistake I promised to tell you about. Most freshers either give a generic, copy-pasted answer for why Accenture, or they say, I don't have any questions at the end. Both are red flags. Research one specific thing about Accenture's work, their projects, their tech stack, their client work, and always ask at least one thoughtful question back. And that's the complete roadmap: over 230 real interview questions across 12 topic areas. Everything you need to walk into your Accenture interview fully prepared. I've also put together a clean, organized presentation covering everything in this video. If this video helped you, hit like, subscribe for more interview prep content, and drop a comment. I read every single one. Good luck. You've got this. See you in the next video.